This is Tim Bryce with my column entitled, Conquering Your Math. I recently sat down with a local college professor of management to talk shop. Like me, he understands the necessity of tracking numbers in business, but appreciates the need for mastering socialization skills to engage people in completing project assignments and solving problems. In the course of our conversation, I asked him what should a high school student master before embarking on a business management curriculum in college. He pondered this for a moment, then, without hesitation, he said, "Conquer your math." I asked him what he meant by this remark. He explained a degree in business management involves a variety of skills to be mastered. Sure, students will use math in finance and economic classes, but they shouldn't be learning algebra and calculus at the same time. It will only slow them down. Instead, they should come with such courses already under their belts, thereby not wasting time and making management courses more meaningful. It has also become apparent high school students do not appreciate the role math has in our professional lives after school. Why do I need to learn it? I'm just going to use financial software, spreadsheets, and computer calculators to manage my finances. It is this growing dependency on technology which is ultimately deterring the need for mathematics. Math teachers have difficulty articulating how it is used, and they certainly should not say something like, "I teach it because that is what I'm paid to do." Just about every profession requires some form of math in one capacity or another. You would be hard-pressed to find a job that does not require it. For example, math is essential for building contractors and construction workers, including plumbing and electrical workers. Architects and engineers cannot possibly design anything of substance without math, not just height and length, but structural capacity and load limits. Chemists require math in order to mix chemicals and create compounds for pharmaceuticals. Accounting involves the use of ledgers and other financial tools. Insurance companies use math to make claims adjustments, adjudications, and property appraisals. Math is used to solve crimes, extinguish fires, and tending to farms. Even the preparation of IRS tax forms, such as your 1040 Schedules A and B, which is something all adults must address, is a form of math we cannot avoid. Homeowners must also be cognizant of their mortgage and other loans, not to mention their bank and financial accounts. Oh yeah, let us not forget credit cards, other expenses, and how our paycheck is calculated. In my niche, the information systems world, math is actively used in both systems and programming. For example, a feasibility study is used to analyze a business problem or opportunity. There are several components to this study, such as the project scope, current systems analysis, requirements definition, system solution, and a cost evaluation summary. It is this last component, cost evaluation summary, that is critical for making a project decision, meaning go, no go, or revise. This involves estimating the time and cost involved in a project, calculating a schedule, and performing a cost-benefit analysis. The cost-benefit analysis considers both the project costs and operational costs, before and after. From this, we can calculate the break-even point for the project, which is a point in time where cost savings match accumulated development expenses. It's typically calculated as investment divided by average annual savings. Also included is a return on investment, which is the ratio of projected cost savings versus amount invested, and it's typically calculated as the average annual savings divided by investment times 100. Such figures are extremely important to executives. For example, I know of companies who will not touch a project unless it has a minimum of 200% return on investment. In addition to feasibility studies, you find math in programming, particularly when analyzing transaction processing. For example, volume of transactions versus time to process. This is critical for determining a suitable software solution, not to mention calculating database capacity. You also see math in such things as project or system audits, where project expenses and schedules are evaluated, requests for proposals, and business plans in general. You can run from math, but you certainly cannot avoid it. This is why the professor's comment about conquering your math is so well put. Friends, keep the faith. This is Tim Bryce in Palm Harbor, Florida. Follow me on the internet at timbryce.com.